Okay, hi ladies. Today we're going to look at solving rational equations um, while I'm gone. But first though, I'd like you guys to try this warm-up. This is just reviewing everything we've done so far. So either way you're listening to this, I want you to pause it and work on these problems. So this one is simplifying. So you're just going to, again, simplify by factoring and canceling common factors. This one's division, so you're going to factor it, make it a multiplication problem, cancel out common factors. Addition and subtraction, you need to find the common denominator. So again, pause this and give it a shot. Okay, so hopefully you have paused this and worked out these problems. So let's take a look. So this first one, I factored the numerator to take out an x, left with x plus 5. Denominator was difference of squares, canceled out x plus 5, and I was left with x over x minus 5. Division, I factored this numerator to be x plus 5, x plus 2. Factor the denominator by taking out a GCF, and I got 3x, x plus 2. I changed the division to multiplication and flipped. So now 7x went to the numerator. I factored the denominator to be x plus 5, x minus 1. And now I began to cancel. So I canceled the x plus 5s, canceled the x plus 2s, canceled this single x with this single x, and I'm left with 7 over 3 x minus 1. Okay, addition and subtraction. Again, with subtraction here, we need a common denominator. So this first denominator is just 8x, so I'm going to need that in my common denominator. Second fraction, I was able to bring out an 8, so I can think about that as 8 times x minus 1. So I already have an 8 in my common denominator, but I need that x minus 1. So common denominator is 8x, x minus 1. I rewrite both fractions with that denominator. To this first fraction, I need to multiply the x minus 1. So this requires foiling. So I have to FOIL x plus 2 and x minus 1. And I get x squared plus x minus 2. Subtracting. And then for this fraction, to have this denominator, I need to multiply by x. So I get x squared minus 7x. So now it's all over the same denominator, and I combine like terms. So my x squared minus x squared cancels. I have 1x minus negative 7 gives me x plus 7x, so it gives me my 8x. And then I have my negative 2. So I get 8x minus 2. Okay, so hopefully this gave you a quick review of the other types of rational expressions we've looked at. Today is actually a little bit simpler than all of this, but a little bit different. The big difference and focus today is now we're going to be solving rational equations. And like we said before, when we get to the end of a unit, we normally bring in an equation, which means bring in an equal sign. And in this case, which you guys will probably be happy to hear, is now we actually get to where we're going to get answers like x equals something, instead of just simplifying and leaving it, kind of as an equation. So the rules here, steps here are a little bit different. So first, we're going to factor all the denominators, okay, really only the denominators. We're going to find our least common denominator, just like we've been doing. But now we're going to take that denominator and we're going to multiply every term by that denominator on both sides of the equal sign. And what that will do is it will cancel out all the denominators. So this will get rid of the denominators. or the fraction part of our equations. And then we can simplify and solve the equation. Okay, so let's get started. First, let's look at this simple one. This really doesn't have variables in the denominator, but if we look at our denominator and we have a 6, a 2, and a 3, our least common denominator will be 6, right? Because 6 is a multiple of both 2 and 3. So we found our common denominator. Now we're going to multiply every term by 6. Again, to wipe out those fractions, just like we learned last semester at the very beginning of the year, how to wipe out a fraction. So when we multiply everything by 6, in this first term, the 6's cancel, and we're left with 2a plus 1. Bring over our plus sign. On this next term, 2 goes into 6 3 times. So we get rid of our 2 and we make our 6 a 3. So this term becomes 3a equals, this last term, the 3 goes into 6 twice. So now we're going to distribute that 2 and we get 2a minus 2. So now we've got a very simple one variable equation to solve. So we get 5, we collect like terms, we get 5a plus 1 equals 2a minus 2. We solve for a by subtracting a from one side and getting all the numbers on the other. So we get 3a equals negative 3, a equals negative 1. Okay, so to recap this, again, we find our common denominator. We multiply every term by that denominator to wipe out our fractions. And if you chose the correct common denominator, it will wipe out all your fractions. Then you simply solve the equation we have left. Okay, so let's just try some more. Looking at this one, again, this is kind of even a more easier problem where we just have two fractions on either side. So our common denominator is x minus 2. If we multiply every term by x minus 2, we can see that it cancels on this side and we get 4. It cancels on this side and we get x minus 1. We can add 1 to both sides and we get x equals 5. Okay. So again, because of this equal sign, that's what allows us to multiply every term by the same thing. And because we have two sides of the equations, it all keeps the equation equal. Okay. So if we look at the next one. So we can look at this equation. We have, again, we have one term on this side, one term on this side, same denominator. So we can multiply both sides by that denominator. It cancels out over here. We get x minus 1. It cancels out here. We get x squared plus 2x minus 3. Now we solve. Again, it looks like we're going to have to factor, right? Because we have some x squareds and some x to the first. So we need to, so if it looks like we're going to have to factor, remember you can't factor unless an equation is set equal to 0. So in this case, we're going to set the equation equal to 0 by subtracting that x and adding that 1. And we get x squared plus x minus 2. So now we have an equation to solve. So we have, it's a quadratic with 3 terms. A is 1, right over here. We know how to solve those by factoring. So it multiplies to negative 2, adds to positive 1 with the x plus 2 and x minus 1. So our answer is x equals negative 2 and 1. Okay. Okay, now at this point, though, I do want to bring up something. I'll talk more about it next class. But when you look up here, if we looked at our domain restrictions, I kind of haven't mentioned that yet this lesson. But if we looked up here at our domain restrictions, we can see that x cannot equal negative 2, right? Because that's the value that would make the denominator 0. And so if x was -2, we would end up having a 0 on the bottom of a fraction, and that would be undefined. So when we find our answers for these equations, we do want to check to make sure the number is not restricted. So we want to make sure the number is part of the domain. Well, we can see that -2 is not part of the domain. So we actually, our final answer would just be x equals 1. We have to disqualify -2. Okay. All right. Let's try another one. So if we look here again, let's start out with that. So this x -3 is factored, x + 3 is factored, x² - 9 is x - 3, x + 3. So now when we set up our domain restrictions, we have that x cannot equal 3 or -3, right? Because those values would set the denominator equal to 0. Okay, so let's just start with that so we know if we find one of those values as our answer, we have to kind of disqualify it. So now we want to multiply each term. So our common denominator is going to be x -3 because we need it for this term, x + 3 because we need it for that term, and then we need both of them for this final term, and we have them. So that will be our common denominator. Now, actually, I'm going to rewrite this up here. Okay. So now I'm going to multiply each term by our common denominator. So I highly recommend that you guys always write the denominator above your equation. You'll see why here in just a second. So write the common denominator above each term, and now we cancel. So this one has an x -3, so I can cancel that x -3. This one has an x + 3, I can cancel it with that piece. This one has both, I can cancel it with both. Now I come back and I distribute or multiply what I have left. So I have x times x + 3 left on this term. So when I distribute that, I get x² + 3x. I have x and x -3 on this next term. So when I distribute it, I get x² - 3x. And on my last term, I have nothing left but 2. Okay, so now I can simplify this equation. So I collect like terms, and I get x. I get x² + x² gives me 2x². My 3x is canceled out, so I get 2x² = 2. I solve by dividing by 2. I get x² = 1. I need to know what x equals, and x² = 1, x equals ±1. I check my domain restrictions, and those are both fine. That's both part of the domain. So I've got my answers. Okay, questions about that? Again, what I did here is I factored each denominator to build my least common denominator. I went ahead and noted my domain restrictions. Then I multiplied each term by the entire common denominator, which enabled me to get rid of my fractions and come up with a simple equation to solve. Okay, let's try one more, or actually 2 more. So we look at this next equation, and we can see everything's already factored for us. So we know our domain restrictions, x cannot equal -1 and -4. And we know that our least common denominator is going to be x + 1 and x + 4. Those are the only factors we have. So now I multiply each term by the entire common denominator. And I cancel out what I can. On this one, I can cancel out x plus 1, I can cancel out x plus 4, and I can cancel out x plus 4. Now I multiply what I have left. So right here, I'm going to multiply x times x plus 4, and I get x squared plus 4x. Next, I'm going to multiply 3 times x plus 1, and I get 3x plus 3. Next, I'm going to multiply x plus 3 times x plus 1, which again, I need to FOIL. So that's going to become x squared plus 4x plus 3. Now I solve my equation, and it looks like I'm going to have to factor. So I'm going to combine like terms over here. I get x squared plus 7x plus 3. And then I'm going to move everything over to one side. I'm going to try to set my equation equal to 0, right? If I need to factor. So I subtract x squared over. I'm going to go ahead and subtract 4x over. I'm going to go ahead and subtract 3 over. You can see something strange is about to happen. So I end up getting 3x equals 0. Okay, so if 3x equals 0, I divide by 3, and I get my solution is x equals 0. I check my domain restrictions, and 0 is not restricted, so it's a valid answer. So x equals 0. Okay. All right, let's try one more. So we look at this one. Again, first let's factor everything. N is as simple as it can get. N plus 1 is factored. To factor this, I can take out n, so I get n times n plus 1. So when I build my common denominator, I need an n, I need n plus 1, and then for this one, I need both of those, and I have them. So this is my common denominator. So now I'm going to go ahead and write this again down here, just because I feel like these notes are getting kind of cramped. And so I've just rewritten my equation down here. I'm going to take my common denominator and write it above each term. So I can wipe out those fractions. So this first one, I can cancel out the n's. This next one, I can cancel out the n plus 1s. Last one, I can cancel out the entire denominator. So this first term, I need to multiply 2 times n plus 1. So I get 2n plus 2. Second term, I'm going to multiply the n times n plus 2. So I get n squared plus 2n. And all of that is going to equal -2. So now I combine like terms. I'm going to keep that n squared out here. I get 2n plus 2n is 4n plus 2 equals -2. So now it looks like I'm going to have to factor. So I'm going to have to set it equal to 0. So I'm going to add 2 to both sides. And I get n squared plus 4n plus 4 equals 0. So now I think I need to factor. So what is 3 terms? A is 1 right here. So I think what multiplies to 4, adds to 4, is going to be n plus 2 and n plus 2. I set them both equal to 0, and I get n equals -2. That occurs twice. So I could say multiplicity of 2. We know what that means. Now, I did not look at my domain restrictions up at the very beginning, so let's go ahead and take a look at that now. And I can see my domain restrictions would be n cannot equal 0 or -1. And since -2 is not 0 or -1, I've got 2 good answers here. Okay? So again, as you look at the homework, go back over these examples. I've given you pretty much an example of everything you're going to have in the homework. And think about these steps you're going to follow, where you factor the denominators to build your least common denominator, your least common denominator. Multiply every term by that common denominator to get rid of the fractions. This is a little bit different than the homework and the warm-up that we did previously. Then you can simplify and solve the equation. Okay, your homework is, if you look in OneNote, your homework is these 8 problems. Again, you may want to, the first couple up here, the print here is a little bit strange, but you should be able to read those. So all of these should be, again, very similar to what we just did. So do your best, and we'll go over it on Tuesday. You guys have a great weekend. Thank you. Bye.